Okay, so are we ready to learn about arcs and chords? So these are the Common Core content standards and mathematical practices we'll be using in our assignment today. Previously, you've used the relationships between arcs and angles to find measures, and now we're going to recognize and use relationships between arcs and chords, and recognize and use relationships between arcs, chords, and diameters. A chord is a segment with endpoints on a circle. Now, if a chord is not a diameter, then its endpoints divide the circle into a major arc and a minor arc. So here is theorem 10.2 that says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So let's look at a real-world example. We're going to use congruent chords to find arc measure. Suppose we have a circular piece of jade and it's hung from a chain by two wires around the stone. We are told, as you see in our diagram, that segment JM is congruent to segment KL, and that the measurement of arc KL is 90. So we're to find the measurement of arc JM. Well, segment JM and KL are congruent chords, so the corresponding arcs are also congruent. So since measurement of KL is 90, the measurement of arc JM is also 90. Let's try this out on our own, so pause the video for a moment and come back and check your answer. So here we're shown that these chords are congruent, and we're told that the measurement of arc RS is 85, and since the chords are congruent, we know that the measurement of arc TV is also 85. Very good job. Now let's use congruent arcs to find chord lengths. So in this figure, circle A is congruent to circle B, and arc WX is congruent to arc YZ. So now we're to find the measurement of WX. So why don't you take just a moment to draw these down, sketch these in your notes, so that when we go on to work the problems, you will have them. So by definition of congruent segments, Yx is equal to, or Wx is equal to Yz, so we set the two quantities equal to each other and simply solve for x. Now we're not quite done. Now we need to go back and substitute what we got for x in for x, because we're trying to find the measurement. So Wx is equal to 26. Okay, time for you to check your progress. So pause for a moment, then come back and check your answer. Because the two circles are congruent and the two arcs are congruent, we can set 3x minus 5 equal to 2x plus 1. Then we're trying to find the measurement of LM, so we're going to plug in, I got x is equal to 6. Substitute a 6 in for x, and you get 13. Now let's look at bisecting arcs and chords. If a line segment or array divides an arc into two congruent arcs, then it bisects the arc. We have two theorems, theorem 10.3 and 10.4. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. And then 10.4, the perpendicular bisector of a chord is a diameter or radius of the circle. Let's put this into practice by using a radius perpendicular to a chord. In circle G, the measurement of arc DEF is 150. Now notice it's 150, not 180. This is a chord, not a diameter. It does not go through the center. So we're to find the measurement of DE. So radius EG is perpendicular to chord DF, so by theorem 10.3, we know that segment EG bisects arc DEF. Therefore, the measurement of arc DE is equal to the measurement of arc EF. So by substitution, the measurement of arc DE is 150, is what we're told, and we divide it by 2 because it's been bisected, or 75. So you check this on your own. In circle Z, the measurement of arc WX is 160. Find the measurement of arc UX. Very good. 160 divided by 2 would be 80. Excellent job. Now we're going to use a diameter perpendicular to a chord. before I get started on this one, I'd sketch this drawing because we're going to lose it here in a little bit. And also note what's being given. The ceramic stepping stone below, the diameter AB is 18 inches long. Okay, this is 18. And chord EF is 8 inches long. We're asked to find CD. So we're going to draw a radius CE. We know that and this forms a right angle because every radius on a circle has the same measure. So AB is 18 and CB is 9, so all the radii of a circle are congruent, so CE is also equal to 9 inches. Since diameter AB is perpendicular to EF, AB bisects chord EF by theorem 10.3. So we know that DE is 1/2 of 8, or 4 inches. Now we can use the Pythagorean theorem since we've got a perpendicular bisector and substitute to find out what the measurement of CD is. If we use our calculator to take the square root, it's about 8 6/100 inches. Okay, let's check your progress. So draw the figure, sketch what it is you know about it, write your given, and then come back and check your answer in a bit. Okay, so we know that QS is 14, RT is 10. So we know that SV is 7, which means RV is also 7 that we're going to sketch in. So our VU will be, or RU is 1/2 of 10, so that's 5. So we're going to set it up 5 squared plus VU squared is equal to 7 squared. And I get the square root of 24, which is approximately 4.90. In addition to theorem 10.2, you can use this theorem 10.5 to determine whether two chords in a circle are congruent. So in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So we're looking at circle P. EF is equal to GH, so we're told these two chords are equals, so we're trying to find the measurement of PQ. Well, since chord EF and GH are congruent, they are equidistant from P. So PQ is equal to PR. We'll set the quantities equal to each other by substitution, and then in order to find PQ, we're going to substitute 3 in for X and find out that PQ is equal to 9. Okay, time for you to check your progress. Come back and check your answer in a moment. Very good. We can set 3x minus 6 is equal to x plus 8 because we're told that these two chords are equal. That means they're equidistant from the center. And I solved and found out that x is 7, and we're to find RS. So substitute 7 plus 8 is 15. Okay, very good. You're ready to begin your assignment.